All right, so do you see that first slide there?
Yep.
Yes.
Okay, excellent. All right, so today, as Paul already mentioned, I'm going to be describing the cornerstones of the wildfire crisis strategy here in Southern California. And so there's a lot happening in the wildfire space in Southern California, and that's true more broadly across the state. And so one example of this is the state and the Forest Service have pledged to treat 500,000 acres each, so 1 million acres total by 2025. And this has led to some massive investments in risk reduction and fuels treatment work. And the primary approach that the Forest Service has taken to reduce wildfire risk has been through the wildfire crisis strategy. So there's a lot of money tied to being a priority landscape. And we are a priority landscape here in Southern California. And so I'm going to give you some background on how the wildfire crisis strategy is being approached on our landscape more locally. Let me see here. All right. So there have been 21 designated landscapes throughout the Western US. 10 of these were selected in 2022, and you can see those as these hatched polygons in this map. And then another 11 were brought on board in January of 2023, and that included the Southern California landscape. So all 4 of the Southern California forests, so that includes the Los Padres, which you all are quite familiar with, the Angeles National Forest, the San Bernardino, and down here in San Diego, the Cleveland. And so collectively, that's 4 million acres. And we call ourselves the Southern California Fireshed Risk Reduction Strategy Landscape. And so the criteria for inclusion as a priority landscape is there has to be wildfire exposure to communities, and there's a particular interest in reducing risk to the underserved communities. There's also a criteria for reducing risk to critical infrastructure, and this can include roads, power lines, and utilities. Considerations are also made to wildfire impacts to municipal water supplies. And the other thing that is important is the scale at which the investment will actually help reduce risk. And so in Southern California, the scale, both geographically, is quite broad, but also the ability to reduce risk to the 25 million residents that live in Southern California also fits well with what the wildfire crisis strategy is trying to achieve. And so we also, one thing that was taken into consideration, I think that this could be an interesting point for this group, is partnerships, and our ability to work well in Southern California with other groups was taken into consideration because we know that the investment from the federal government into the wildfire crisis strategy, we as part of the Forest Service don't have the capacity internally to take on a lot of these projects. So it's critical that we work with partners. And so we have a track record across Southern California of working with RCDs, fire safe councils, the RFFC grantees from the Department of Conservation, and local governments and tribes. And so thus far, there's been $1.6 billion invested into risk reduction across these 21 landscapes. And this money is coming from the Inflation Reduction Act as well as a bipartisan infrastructure law. So a document that really framed the wildfire crisis strategy was produced about 3 or 4 years ago. And so you can see that document here. There's a website for you to take a closer look if you're interested. And it really outlines the problem leading to the current wildfire crisis. It includes a section on climate change and climate change effects on drying fuels, and also the effects of climate on suppression operations. And it spends a lot of time focusing on the wildland-urban interface and increasing risk to communities as the WUI expands. And then the part that I find interesting, it's well done, but the part that I want to point out is that it also highlights fuels buildup and discusses catastrophic effects of fire suppression from the removal of fire from forested ecosystems. And so I think that the Wildfire Crisis Strategy Report, it's an interesting read, and I would encourage you, if you have time, to read it. But when it comes to fuels management, it is incredibly forest-centric. So when Southern California was selected as a priority landscape, there was concern, or at least I can say I was concerned, that some of these traditional forested practices of adding more prescribed fire, adding more thinning would just be, copy and pasted into the Southern California landscape. And the diversity of Southern California landscapes really requires a more nuanced approach. And so we had to ask ourselves, how do we adapt the wildfire crisis strategy when it comes to fuels management to the Southern California landscape? And so I'm sure, as you're all aware, here in Southern California, we're different. Our landscape is largely dominated by chaparral. We do have hardwood and conifer forest, but it's much less common. So the messaging about fuels buildup and fire suppression, it is important, but it's really important for our forested ecosystems, and we need to come up with a plan that really also is suitable for our shrublands. So the maps you can see here, the map on the left, one of the things to point out is Southern California is dominated by chaparral. So that orange color you're seeing is the chaparral dominated landscapes. There's a sprinkling of hardwood and conifer forests. There's some grassland as well, as you can see in yellow. But this is quite different than the Sierra Nevada or the North Coast, that is primarily dominated by forest. The map that you see on the right shows the fire return interval departure, and this basically describes how these lands have changed from their historic burn intervals. So in conifer forest, like those that blanket the Sierra Nevada, fire was quite common before European settlement, and today we're highly departed with much less fire. So that blue color indicates a fire deficiency. There used to be more fire in these ecosystems in the past. There's not as much today. If you now look at Southern California, you'll see there's not quite as much blue. There's a lot of orange and red, and that's in the southern part of the state. And that's associated with chaparral-dominated landscapes, and especially those in close proximity to human populations. So these warmer colors indicate where we've significantly more fire today than in the past. So the approach for Southern California, it needs to be different. And it's not just about getting more fire on the ground, because we already have plenty that puts communities and ecosystems at risk. So I thought to kind of bring it home here that I just share with you the vegetation map for Santa Barbara County. You can see that we all follow suit here in the county. There's one thing that did stand out to me is there is a decent amount of herbaceous or grassland vegetation within Santa Barbara that's shown as this kind of red-brown color. So when we thought about the application of the wildfire crisis strategy in Southern California and on the Los Padres, we wanted to tailor it to the vegetation types we had, and not just, as I said before, follow this conifer forest train that was at the forefront of that wildfire crisis strategy report. And so looking at this vegetation map and kind of thinking about tailoring our risk reduction and our management, I think that the project you all have with grazing and targeted grazing in areas to reduce fine fuels is a perfect example of kind of thinking outside the box and going for more nuanced approaches to dealing with risk reduction. So for Southern California, the Forest Service came up with 4 cornerstones, and this is the infographic that we produced to message these 4 cornerstones. And I can PDF up this presentation and send it to Charles if people want to take the time to read these. I think it's a great infographic and that you'll find it useful. But the 4 cornerstones can be distilled into these 4 points on the left side of the slide. First off, forest health and fuels reduction in montane forest. So this is not novel. This is kind of well developed in the wildfire crisis strategy. The second approach is quite novel, and out of all the 21 landscapes that have been identified or prioritized, we're the only landscape that's taking on this roadside ignition reduction approach. So it's pretty exciting, and I'll talk a little bit about that today. Third, we have a plan for the maintenance of strategic fuel breaks. Kind of want to highlight strategic here, and I'll tell you about how we're shifting our thinking a little bit about fuel breaks, where to put them, and which ones are maintainable. And then finally, there's a cornerstone focused on community protection. And I won't be touching on this today. I feel like we really are able to accomplish a lot of this community protection work through our partnership with fire safe councils. You talked about in your meeting earlier, the work that you're doing for fire-wise communities, for defensible space, for home hardening. And this is how we really are able to make sure that our communities next to the Forest Service land are being protected. So this last point here is really through, work and collaboration with groups like yours. All right, so I'm going to start here with forest health and fuels reduction in the montane forest and walk you through the process and where we're at with developing this particular cornerstone. Okay, so since 1985, we've lost about 15% of the tree cover in Southern California. And we also had the fastest loss of forest compared to all other parts of the state. So we don't have much conifer forest in Southern California. There's a real need to conserve what we do have. And so we took on this challenge by developing a climate-informed montane forest conservation strategy. And our vision, here's our vision statement here, our vision was to work collaboratively to maintain montane forest ecosystems in Southern California Sky Islands and to sustain the ecosystem services and benefits they provide. And so we developed this strategy through a collaborative process that included the Climate Science Alliance, who's a group who really specializes in tribal engagement. We worked with San Diego State University. Obviously, the Forest Service was involved, and USGS Southwest Climate Adaptation Science Center funded this, the development of this strategy. Let's see here. There we go. And I am happy to say that the strategy was released this summer. It was a heavy lift, and I think it's a really great document that will help guide forest actions, management, reforestation, restoration in the right direction. And so within this montane forest conservation strategy, there are 3 parts that I'm going to break down and talk to you about in some detail. And the reason that I think it's important to discuss the elements of the montane forest strategy is we do host workshops throughout Southern California, outreaching this strategy and holding prioritization workshops. And we will be coming up to the Los Padres in the next 4 to 6 months. So we're hoping that some people from the Santa Barbara Fire Safe Council can attend these meetings and learn more and get involved in our montane forest management. So within this strategy, there are 3 prongs. There's a prioritization framework for forest resilience. There's an adaptation menu for climate and climate adaptation. And then third, there's post-fire restoration strategy and framework that has been developed. So I'm going to start off with that first part, prioritizing forest resilience. And we really wanted managers to move away from doing forest health work in areas that were easy, convenient. We wanted them to start thinking more holistically. So we developed this framework, which is essentially a mapping exercise, and it has 3 steps. So the first one is we evaluate exposure to risk, and this is really where we bring in climate change. Then we identify vulnerabilities to the forest. And that last step in purple is where we overlay priority assets. So these would be cultural or biological, maybe infrastructure, basically resources of value, things we care about. So I'm going to step you through each of these processes and show you how this framework works. And you can start thinking about, relative to the Santa Barbara landscape, what are our vulnerabilities? What are our assets? How would we actually inform this framework, and what might our priorities be within the county and the Los Padres more generally? So the first thing that we do is we created a climate adapted refugia layer. So this takes into consideration climate, fire potential, and human pressures. And refugia, here's the definition of refugia here, is defined as areas where exposure to threats are low relative to the broader region. And so we selected refugia elements to represent factors that we have very little ability to change. So these are static features across Southern California, and they are difficult to change through management actions. So this is a lot of information, but I think that it's I think it's important for you to kind of understand how you might use this mapping product that we developed. So to inform the refugia layer, we had a climate element, as I already mentioned, and this included changes in aridity and changes in the frequency of prolonged drought. We also had information about Santa Ana wind trajectories and landscape position to inform fire potential. And lastly, for human pressures, we included maps of impervious surface. And here is what that refugia layer looks like. And so to get you oriented, over here in the more brown colors on this map, these represent spots of low refugial capacity. So these are areas where exposure to threat is high. And on the far side, in deep green, so at the other end of the continuum here, we have areas of high refugial capacity. So these are areas that are buffered from those threats. And these are areas that we're most likely to maintain forest into the future. And that's really key. These areas that are found within refugia are areas that might be best for us to invest in forest health work. And so this map and the maps that I'm going to show you in the next few slides focus on the San Bernardino National Forest. We held the workshop there about a year and a half ago, and we now have mapping products that we've shared with them. So these maps, so just to orient you, this is, Big Bear Lake is this area in the middle that doesn't have vegetation, and then we have Idlewild down here on the San Jacinto Ranger District. So we will be producing very similar products to this for the Los Padres and the surrounding communities. The next step is to identify vulnerabilities, and we do these through a partner workshop. And so we invite local managers, partners, stakeholders to come into the workshop, and we ask people to help us identify vulnerabilities. And these are weaknesses in the protection of a forest or a forest asset. And I think the important part here is that these vulnerabilities are things that we have the ability to change or improve. So let's say, in the workshop, and this has come up as we've moved around the landscape asking about forest vulnerabilities, a lot of people say surface fuels. Surface fuels put these forests and forest, functioning and services at risk. And so from a management standpoint, that is really important for us to know, because we can go in and we can change that vulnerability. We can improve that condition through pile burning or the use of broadcast burning. So that is how vulnerabilities work. In the workshop, we pulled together a list of vulnerabilities, and then everybody has a dot, and they get to vote on the vulnerabilities that they feel are most important. And we compile all of that into a map. For the San Bernardino National Forest, I just thought it's interesting. For people usually like to see what vulnerabilities other people have come up with for other parts of Southern California. And these were the vulnerabilities that really stood out for forested landscape: downed woody fuels, stand density, departure from fire return interval, ignitions, as well as human pressures. And then here's the map that's generated. So these show, in these darker colors, the high vulnerabilities. So these are areas that we would want to focus on for helping to bring the forest into a condition that is going to be more resilient to wildfire, other disturbances moving forward. And so the last step is to include priority assets. And so these are areas of ecological, cultural, or ecosystem values. They're also flexible, and as we move around the subregions, we identify assets that are important to that particular landscape. So on the San Bernardino, their assets that were identified was watershed and water supply, protection of human communities, sensitive species, as well as recreation and infrastructure. So we pull all of these three layers together, the refugia, vulnerability, and assets, and we create a map that prioritizes areas that have high refugial value and are most likely to persist into the future. So these are the areas that are most vulnerable to stand replacing fire, and where there's the greatest assets that could be lost by fire. And so this process can be then fed into project planning, like selecting areas where to do NEPA is the primary way we've used it thus far. But we've also had interest in using these maps for already planned project where there's uncertainty about where to start treatments. So a lot of NEPA or environmental review happens across larger landscapes, and then it lands on the forest lap to decide where do we start. And so this can help guide people into identifying locations to start these management actions where we can do the most good. Okay, so that was really the focus on the prioritization framework. The second part of the montane forest conservation strategy focuses on adaptation to climate stressors. So we utilized two documents that have been produced. There's a climate adaptation menu that was produced by the USDA Climate Hub for California, and there's also a tribal a tribal adaptation menu that was developed, and we tailored those two documents to be more appropriate for Southern California. And so this adaptation menu, we have developed it as a web interface, so you can type in, say you're interested in gold-spotted oak borer. That's something that's on my mind a lot lately. You could type in gold-spotted oak borer, and it would provide you with the strategies, approaches, or tactics that would allow you to mediate or reduce the effects of that particular stressor. So there's responses, which are very high level, there's approaches, and then the tactics are what you would use on the ground. So for example, for the strategy 2, to reduce the risk and long-term impact of disturbance, the approach would be to promptly revegetate after the disturbance, and the tactic, what you would actually take to the ground to implement, well, this first one is not about implementation. This is more about your approach to securing funding. So the first piece here is to plan for and secure funding to support multi-year planting to increase chances of interception to high rainfall years. And so this particular tactic is one that allows you to have some foresight when you're planning revegetation projects. And this 2.6.10 would be something you would take to the ground when you're doing this implementation. So the example here is to utilize mesic microsites to enhance reforestation success. So this might include using natural features for planting like rocks, pine cones, shallow depressions, downed wood, or nurse plants. So the adaptation menu, while it's been designed for montane forest ecosystems, I do think it has value for other ecosystems like chaparral restoration, for example. Okay, and the final part of the montane forest conservation strategy is the development of a post-fire restoration framework. And so a few years ago, we put together this statewide post-fire restoration framework for national forest. And in the montane forest strategy, we've really tailored that to montane forests in Southern California. So essentially, this post-fire restoration framework is an assessment that can be done on forested landscapes or really any fire scar. It's flexible. So even if you had a fire scar that had all grassland or all chaparral, you could still utilize this framework to evaluate post-fire restoration needs. And so this was published as a general technical report by the Forest Service. And so within a fire scar, and I'm going to show you an example of this with the lake fire in just a moment, but within a fire scar, we divide the landscape down into 3 areas, and those areas are listed here. So these are bins. So you could think about a fire scar and trying to bin the various parts of that fire scar in 3 ways. 1, areas where restoration is not needed and natural recovery will progress on its own. So this is typical of most fire scars. I've done a number of these assessments now, and for the most part, these landscapes are able to recover on their own. But in instances where they're not, we have two additional bins. So the second bin, these are areas where restoration is needed and feasible given current conditions, and it's likely okay to restore to the pre-fire conditions. So there's nothing about the landscape that we think has substantially changed from before to after the fire, and we can move forward with restoration to those pre-fire conditions. And then the third bin focuses on areas where restoration is needed, but it's likely not feasible to restore to the pre-fire condition, and we really need to rethink our restoration goals. So this third bin may include novel conditions on the landscape that will prevent the reestablishment of the same species that were there in the past. And this could have to do with climate change and drying conditions, or perhaps the landscape is frequently disturbed and is, being disturbed at very short intervals, and this could get in the way of planting success. So a good example here to think about would be degraded chaparral that's continually burning. Perhaps rather than trying to put the same species back, long-lived, let's say cedars or resprouters, maybe we need to reevaluate those desired conditions. So essentially, we parse these landscapes out into these three bins, and here is the lake fire. And I, over the next few months, am going to be doing this post-fire restoration assessment on the lake fire. So this is a good opportunity for me to start pulling together the various layers that I will need to do this analysis. But the first thing that I want to point out is that this ecosystem, the ecosystems that burned within the lake fire, are a broad mosaic, and they're and it's important to evaluate the ability for these ecosystems to recover by vegetation type, because each of these vegetation types has a unique relationship with fire. So most of the lake fire was dominated by shrublands with very, very small amount of conifer forest. And so when we take into consideration the elements of fire that can disrupt conifer forest recovery, we see that the conifer forest, while it only makes up 6% of the lake fire, it actually did burn quite severe and in large patches of high severity. All right, so here is a vegetation burn severity map where I've just pulled out the areas of high severity fire, I've just pulled out the areas of conifer forest. And so this map is showing you a change in basal area loss, which is, you can think of as a measure of surviving trees. So it's a typical way of describing stand density, or a change in stand density. So for conifer forests that burn at high severity over large patches, these ones are at the greatest risk. And you can see in this picture here, this is at Figueroa Mountain, and this was taken 1 month after the fire. So most of the conifers, or all of the conifers, were killed in this landscape, and their cones and seeds had also been consumed by the fire. And so it's really essential for there to be green trees nearby and in close proximity to serve as a seed source. So larger stand replacing fires, like we saw in parts of Fig Mountain, may have a difficult time recovering. And so in the photo, you can see that all the trees, this is a mix between hardwood, largely coast live oak and ponderosa pine, they have all been, the ponderosa pine have been killed, the coast live oak have been top killed, and they are resprouting from the base. So you can see a little green tuft here, there's a little green tuft over in this corner. And so even a month post-fire, we see the oaks reestablishing, and the conifers they do not have the ability to resprout. So on this landscape, we need to think about the next steps. And so when we look at the percent of conifer forests that burned at high severity in the lake fire, over half, so 54%, were highly affected. And that means they lost greater than 75% of their basal area. So from a preliminary look, there's greater than 1,000 acres, so over 1,000 acres that will be in need of reforestation. If we decide, we're hoping to reforest in these areas, and there is a new funding mechanism with the Forest Service called BAR that covers reforestation and restoration. And so we will be applying for BAR funds to do reforestation in some of these high severity burn patches. If we don't receive those funds and we're unable to reforest in these areas, then it's very likely that these parts of the lake fire and largely Figueroa Mountain will start to move towards hardwood forest. And so there are a few green patches that are left that have conifers, like the Pino Alto Deus area. So that's up at a ridge top. And so it didn't burn at high severity. There is a possibility for those green trees to contribute seeds to the slopes down below and help with conifer reestablishment. But we are hopeful that we can take some active reforestation in this area. Okay, so going back to the wildfire crisis strategy and our first cornerstone, forest health and fuels reduction in montane forest. This montane forest strategy that we developed really encompasses all aspects, and Southern California is utilizing this climate adapted conservation strategy for really driving this particular cornerstone forward. Okay, so next we're going to move on to roadside ignition reduction. And as I mentioned before, this is really a novel approach for the wildfire crisis strategy landscapes. And as far as I know, we are the only landscape that's adopting this type of work. It's important in Southern California because we have so many human-caused ignitions. About 95% of our ignitions are human-caused, and we need to figure out how best to deal with excessive ignitions. And so for starters, the first thing that we did when we considered including roadside ignition reduction as one of our cornerstones was to have a proof of concept that there's a relationship between ignitions and roadsides. So we created a dashboard that you can see on this slide for the 4 Southern California forests, and we overlaid human ignition data from the last 20 years onto maps of our roads and trails. And we found that 65% of ignitions occurred within 500 feet. And so over the last 20 years, that's 6,203 ignitions. It's pretty significant. And we also found that 10% of ignitions occurred within 5 feet of trails. So we knew a good target for reducing ignitions was to focus on roadsides and trails where humans are abundant. And so just to get you oriented with this map, and I can send the dashboard to people who are interested, but the purple squares represent ignitions along roadsides, and then the green diamonds represent ignitions along trails. So there are many approaches to reducing ignitions, and all of them are important. It should be considered. But some of the strategies that we identified include education and efforts aimed at changing behavior, and really, kind of going back to the one less spark messaging. We also have heard a lot of emphasis on increasing fire patrols, which additionally is a form of education and being proactive, trying to get the fire before they even start. There's also been discussion of using long-lasting roadside retardants, as well as establishing roadside barriers like the fencing that you see up here. I think this is on Highway 15. People have also talked about roadside barriers in addition to fencing, using concrete K-rails on the sides of highways to prevent cars and sparks from getting into flashy fuels at the roadside. And so while all of these strategies are important, for the wildfire crisis strategy, we decided to focus our efforts on vegetation management. So the bottom photo is from East Camino Cielo. This is one of Robert Fitch's study sites. And we've been working really closely with Robert and with Carla to figure out ways to do vegetation management that can reduce ignitions. And so to support our focus on vegetation management as the primary effort that we're going to take on as part of the wildfire crisis strategy, we are interested in establishing a relationship between ignitions and roadside vegetation. So we contracted a group to map the percent cover of non-native flashy fuels along roadsides. These non-native flashy fuels were predominantly non-native grasses, and this mapping effort was 30 feet off of the roadside, and it covered about 850 miles of roadways throughout Southern California. And then we overlaid ignition data from the last 10 years, and we found that once non-native grass cover reached 50%, that ignitions doubled in density. And so here's our non-native grass cover. So once we got to this 50% of flashy fuel cover on that 30-foot buffer along the roadside, we had a jump in ignition density that doubled from when non-native grasses was much lower. And then when we reach greater than 75% non-native cover in our roadsides, we had a 5-fold increase in ignition density. So this really piqued the interest of the Wildfire Crisis Strategy group in Southern California enough to move forward with vegetation management as the focus for this ignition reduction work. And so there's really 2 steps in, if our target is, changing the roadside condition, there's 2 steps to get there. One is controlling flashing non-native fuels. And there are many ways to do this. Many of them have been employed for decades throughout Southern California, and they include things like mowing, burning, grazing, and the targeted grazing work you are all doing on fine fuels, herbicide, mulching, solarization, blading. And so there's a lot of choices. And we found that this list of potential non-native grass control methods was a bit overwhelming. And so we are working with the California Invasive Plant Council, CalIPC, to develop an invasive weed toolbox. And so I will show you a draft of one of their decision trees in just a second. They have been working on this for the past 6 months, and they now have a draft that's out for people to review. So I know some of you have on this call have been pegged as reviewers, and so hopefully you can make tomorrow's call and learn a little bit more about the effort. So once non-native flashy fuels are reduced, it's important to restore with less ignitable species. And so we've been partnering with Robert Fitch, who's a graduate student with Carla. And I know he spoke to you a few weeks ago, so I'm not going to go into great detail about Robert's work, but this is really key part of being successful with the roadside ignition reduction is being able to remove the non-native flashy fuels, but then get native, less ignitable species in that can hold the landscape, make it less likely that non-natives can reinvade these areas where we've done our control work, and also just kind of hold the landscape. And so this effort is something that is ongoing, and Carla and Max, Robert have just received a NIFWIF grant to continue with their science support on this project. Here is, as I mentioned before, here is a decision tree that was developed as part of this invasive weed toolbox through partnership with CalIPC, and it essentially helps us tailor the control methods to the particular landscape. Roadside environments are quite diverse as you move throughout Southern California, and so it's really important that we're utilizing approaches to reducing weeds that are going to be most beneficial for that particular landscape. And so this decision tree asks questions about whether or not there's desired vegetation present. Are non-native perennial weeds present? Is the site larger than 1 acre? And it leads you to a specific approach. And if you go to the approach document, it will tell you what are the best methods to use out of this list. There might be even a few more methods that they include in their report. And it also tells you what season you should be applying these methods and whether or not certain methods are better layered on others. Should you herbicide? Probably not herbicide, then graze. Maybe should you graze and then herbicide? And so I think it's going to be a really useful guide for helping reduce non-native flashy fuels. So we do need reviewers for this. If you have any interest, please let me know, and I can tell you more about this tool. One of the fun things that's a little bit different that we have tried here in Southern California to reduce flashy fuels is the use of the burn bot. I'm not sure if you all have ever seen this crazy machine demonstrated, but they describe the burn bot. So this is a picture I took of it. It kind of looks like something out of Mad Max from Beyond Thunderdome. But they describe it as being able to integrate the ignition, containment, smoke management, and mop up all within a continuous sequence. So originally, I think the original idea with developing the burn bot was that it could actually create a black line around burn units, and then it could be used to be the containment line for prescribed fire. But since that time this was developed, many people have started coming up with additional ideas on how it can be used. And so in Southern California, we thought, well, we really need for these roadside environments to remove the vegetation that's growing, and ideally to start killing the seed bank, because the seed bank can be, these non-native grasses can produce quite the seed source, and it's essential to be able to remove the plants as well as the seeds in order to be successful here. So we did a trial on the Cleveland National Forest, and we set out to ask these two questions. One, can the burn bot reduce non-native grasses? And two, can it kill seeds in the seed bank? And we measured a whole slew of things, but I think most relevant to today is that we measured plant cover before and after the burn bot. We measured live fuel moisture. We had thermocouples to get soil and surface temperatures. And then we also took soil cores to evaluate how the seed bank changed before and after the burn bot came through. And so this was the unfortunate part about this. We had planned for the burn bot to come down to the Cleveland National Forest in April of this year. And unfortunately, we had a rain event right before then. So live fuel moisture was quite high. So we set up plots in areas that had high live fuel moisture. So the top photo here is showing one of our plots in close proximity to an oak. So high live fuel moisture because it was shaded for most of the day. This is ripgut brome, really, dense growth of ripgut brome with very high live fuel moisture. And so when the burn bot came through, it was only moderately effective. And so you can see from this bottom photo here that it wasn't able to consume all the grass. I revisited these sites about 2 months later, and indeed, much of the grass did come back in this more mesic site. And for the second question, was it able to kill the seed bank? No, we haven't even processed the soil cores, because when we walked up to these burned areas, we could actually still see seed laying on the soil surface. So this isn't to say that the burn bot is not effective for this purpose, but at least for springtime, when live fuel moisture is high, it probably is not going to be able to give us the impact that we're looking for non-native flashy fuel reduction. We did also have study sites that were more dry, so away from oak trees, in much drier environments out in the grassland. And we did find that in these drier sites that there was complete grass consumption. And one of the things I want to point out is that in these drier sites, there was a combination of grasses and forbs, some desirable species like California aster or Corythrogeny. Some of you might be familiar with it. And what we found is after the burn bot went through the grassland, that the grasses were consumed, but some of these desirable forbs that had higher live fuel moisture survived. So there is an opportunity to perhaps use the burn bot during certain times of the year when grass live fuel moisture is lower and forbs, desirable forbs, are higher, and we can maintain the forbs on the landscape while getting rid of the grasses. I think the seed bank issue is still something that needs to be addressed, because it is really important for us to start knocking back that seed bank if we want to really have a durable solution for this roadside ignition reduction work. Okay, so for roadside ignitions, we have a partnership that we formed, and this is called SCIRP. It stands for Southern California Ignition Reduction Program. We have a charter that we've put together that's been signed by CAL FIRE, Caltrans, Department of Conservation, National Forest Foundation, and a couple of conservation finance groups. And we have monthly meetings. I think they're really informative. We have a lot of the regional fire and forest capacity grantees who sit in on these calls and participate in the calls. and many of the RCDs do as well. So if there's any interest for the Santa Barbara Fire Safe Council, let me know. I head up the Vegetation Management Committee, and so we meet quarterly and we talk about some of the stuff that I've just presented. So currently we have 3 pilot projects, one on I-8 in San Diego, one on the Cajon Pass, one on the Ortega Highway. But with the recent NIFWIF grant received by Carla and others, we're hoping that East Camino Cielo or some location on the Los Padres can also be included as a pilot. And we've been lucky to have UCSB providing much of the science support for this work. We have California Invasive Plant Council creating the invasive toolbox. We have S&S Seed, who's bulking seed for the forest, because as I mentioned before, it's a 2-step process. We have to get rid of the weeds, and then we have to come in on the back end with seed to restore these areas with less ignitable species. And lastly, there's a prioritization mapping that's currently underway. Okay, so moving to the final cornerstone for the wildfire crisis strategy, this is the maintenance of strategic fuel breaks. And so what's really critical and different about the conversation surrounding fuel breaks is that there's interest in honing in on strategic fuel breaks. And I really want to emphasize, kind of underline the strategic part of this. And so these are areas that can be staffed safely during suppression. And these are areas that are feasible to maintain. And they're also areas that can reduce risk to critical infrastructure and communities, as well as reducing risk to natural resources. And so there are 2 efforts that are really feeding into our identification of these strategic fuel breaks. And so the first effort has already been accomplished, and that's here in Part A. And this was an assessment that was done in 2015, and it was conducted over 3,700 miles of fuel breaks across the 4 Southern California forests. And the objective of this first assessment was really to identify the strategic fuel break system with the highest probability of assisting in fire suppression operations and maximizing the potential for long-term maintenance. So this report really serves as the backbone for ensuring fuel breaks were useful from an operational standpoint. Now we have a new assessment underway, and that's Part B here. And the Forest Service really wanted to determine the benefits associated with fuel breaks. So we have the operational piece. Now we need to think about which of these fuel breaks is most beneficial. And so this effort is being developed by Vibrant Planet, the Forest Service Research Station, and Pyrologics, who's a well-known fire modeling outfit. And the goal is to quantify wildfire risk to assets. And this includes structures, recreational areas, water supplies, critical habitat, and the list is actually quite long. And this assessment will determine the potential benefits of proposed treatments to reducing wildfire risk to these assets that have already been predetermined. So the real interesting piece here is that there is a call for projects. And so this map is indicating sort of that buffer. So there's a call for projects within a 5-mile buffer of Forest Service land. And the Vibrant Planet is going to process, if you're interested in including any of your fuels work, they will process and prioritize your planned work and provide potential benefits to risk reduction associated with structures, rec, water supply, critical habitat, all of those assets that I listed earlier. And so the email came out yesterday, maybe the day before, by Jeff Hayes, who's the wildfire crisis strategy lead in Southern California, asking for submittal of project areas. And so the kind of work that is being accepted, I mean, everything's pretty much covered: thinning, mastication, chipping, herbicide use, grazing. So if you have projects that you have planned, I think that the call said current projects all the way out to 2029, and you want to know how those projects will reduce risk to some of the critical assets in the Santa Barbara area, then please do submit your project areas. And if you didn't receive that email, let me know and I can forward it to you. So together, this part A and B, we'll use this older operational assessment together with this newer assessment that focuses on risk reduction to assets, and we'll identify the critical fuel breaks and focus our efforts on their maintenance. So that's how the wildfire crisis strategy is putting a new spin on fuel breaks, really trying to be strategic here, move away from, opening up lines and trying to maintain lines all over the place. Really, let's get into those areas where we can maintain, and we know that there will be benefits to communities and water infrastructure and all of those things. Okay, so that is the high-level overview of the wildfire crisis strategy and how we are implementing it and what these 4 cornerstones are all about in Southern California. So I will stop there. I have a couple more slides because, as I mentioned earlier, I've been thinking a lot about gold-spotted oak borer, and maybe I'll ask if there's any questions. If there's not, we can talk a little bit about gold-spotted oak borer before I turn the mic back over to others.